Okay, so this is simplifying square roots part 2. I realized after I made the first video, we forgot to talk about solving equations and then using square roots to solve for x. So we're going to review that, but real quick, just to go over what we talked about last time. If you have not watched Simplifying Square Roots, the first video, I would recommend doing so to help you solve the next few problems. But to review, we talked about squares. And we said 3 squared means 3 times 3, or writing your base the number of times that your exponent says. So 3 squared means my base of 3 times itself twice. So I get 3 times 3. And we talked about finding the square root, or the reverse operation of squaring something. So I'm taking something that I made 2 of, and now I'm going to start with this piece and try to go back to my original. So that's what we did last video, and why that's useful is because sometimes we're going to use square roots to solve for a specific variable. So it may say x equals something or y equals something. And we're going to use square roots to help us solve. So let's take a look at an example. So it says using square roots to solve for x, or really any variable. The higher you get in math, you'll see thetas, you'll see y's, you'll see, signs, you'll see all kinds of things. But for now, we're going to stick to x's and just plain letters. So the first thing is, how can I get my variable alone? Before we take the square root, I need it to say x squared equals. My equation has to look like this before I can take the square root. Well, if I look at my first example, it says 3x squared equals 12. If I want to get this x squared piece alone, what piece do I need to move? Okay, some of you guys may be thinking, well, Miss Sawyer, we got to move that 3. Well, if 3 is being multiplied by x squared, how can I move that 3 over to the other side of my equal sign? Well, hopefully you guys are starting to divide by 3 on both sides, because if I divide by 3, those 3's cancel, and I'm left with x squared equals 12 divided by 3 equals 4. Well, once my equation looks like this form, I can take the square root of both sides, and I get x equals, well, what's the square root of 4? So most of you guys are saying, well, x equals 2, but we also talked about the fact that negative 2 times negative 2 equals 4, so x can also equal negative 2. You're going to have 2 answers for this equation. X could equal positive 2, and x could equal negative 2. Meaning I could put positive 2 or negative 2 in for x with parentheses, and my answer will be 12. Let's take a look at example number 8. This is a little out of order. Example 8, how can I get x squared alone on one side of my equal sign? Well, some of you guys are saying, let's add 3 to both sides. Hopefully by now that's a comfortable next step for you. And you get x squared, those 3's cancel, equals 8. Well, once it looks like x squared equals, I can take the square root of both sides. So I end up with x equals, well, if I type the square root of 8 into my calculator, do I get a pretty number? No, I get a decimal. So what did we talk about last class? What did we say we can do if you take the square root of a number and it's maybe irrational? Can't I simplify my square root using a factor ladder? Yeah, so what's the smallest prime that goes into 8? Well, 2 goes into 8 and gives me 4. What's the smallest prime that goes into 4? 2 goes into 4 and gives me 2. Well, then 2 goes into 2 and gives me 1. When I get to 1, I know I'm done. So if you don't remember, we called these factor ladders or factor trees. And once I have my tree, I'm going to circle pairs of matching numbers. One circle of pairs goes on the outside of my square root, and everything left goes on the inside of my square root. So x equals 2 times the square root of 2. That is the square root of 8 simplified. So let's take a look at these. These are a little bit more in depth, maybe multi-step problems, not just one step anymore. So if I'm trying to get x squared alone on one side of my equal sign, if I remember my order of operations to move things over, I start from the farthest piece and then work my way to my x. So the first thing I do is subtract 3 from both sides. So I get 10x squared. Well, 3 minus 3 equals 0. So I get 10x squared equals 40. Well, I'm solving for x, so I got to divide by 10 on both sides. So I get x squared equals 4. Well, once I get to x squared equals, I can take the square root of both sides, and I get x equals positive 2. But we also said it could equal negative 2. So if you look back, this was the answer to the first problem we did on the other page. It's just a different way of solving essentially for the same x value. Well, let's take a look at this one. Number 10, I have 5x squared minus 13 equals 87. If I add 13 to both sides, I get 5x squared. Negative 13 plus 13 equals 0. 100. Well, if I divide by 5 on both sides, I get x squared equals 20. Well, once it looks like this, I can say, let me take the square root of both sides. So I end up with x equals, but if you type in the square root of 20 into your calculator, you get 4.472135955, and it keeps going. So I don't want that crazy decimal. That's not a pretty number that I want. But what I do want is for you to use factor ladders. So if I think about 20, what's the smallest prime that goes into 20? Well, 2 goes into 20 and gives me 10. 2 goes into 10 and gives me 5. 5 goes into 5 and gives me 1. When I get to 1, I know I'm done. So I have one pair on my outside. That one pair of 2's goes on the outside of your square root. The leftover piece goes on the inside. So you just simplified your square root into the square root of 20 equals 2 times the square root of 5. So this is simplifying square roots by solving equations, solving equations by simplifying square roots. I'm solving for x using factor ladders. So here's some for you to try on your own. Give these a go and we'll see how you do.